So in section 8.4, we're going to talk about perimeter and area. Perimeter and area is something that you've already learned and you should know. But now we're going to find perimeter and area using polygons that are graphed in a coordinate plane. So it's going to look a little bit different for us. So let's start off by talking about polygons here. We're going to just talk about how to classify polygons. We're going to name them based on their number of sides. And then we're going to tell whether it's convex or concave. So let's start by going through the types of polygons based on the number of sides. We can't actually have a polygon. Think about a polygon is a shape that has sides. We can't actually have a polygon that has one or two sides. So I want you to cross off one or two. We also don't have a special name for a polygon with 11 sides. So you can cross that off. So let's name the rest of them. Some of these you might be familiar with. So a polygon that has 3 sides is called a triangle. That should be, again, something that you're probably familiar with. 4 sides, not a square or rectangle. Although squares and rectangles are polygons with 4 sides, the general term for a polygon with 4 sides is a quadrilateral. 5 sides would be a pentagon. 6 is a hexagon. 7 is a heptagon. 8 an octagon. 9 is a nonagon. 10 is a decagon. 12 is a dodecagon. And then n would basically be anything else. So as you go past 12 or any other sides, we would just call it based on the number. We'd call it an n-agon. And then the other thing I want to talk about, so basically we just have to figure out how many sides there are and then we can name it. The other thing is deciding if it's concave or convex. So concave and convex has to do with the sides and the interior of a polygon. So think about when you have a polygon, the interior would be the part on the inside. So if I were to shade the interior of this polygon, it'd be right here. In order to determine if a polygon is concave or convex, if it's convex, that means none of the lines that are formed by a side would go through the interior. So what that means is if I were to draw these lines for the sides, none of them should go into the interior. So far, neither of them did. But when I draw this line, it goes in the interior right here. Do you guys see that? This line goes through the interior. That means it is concave. It concaves into itself. So this polygon would be concave. I also want to name it based on the number of sides. 1, 2, 3, 4 sides. This is a concave quadrilateral. Let's take a look at the next one. None of the sides go through the interior, right? Do you guys see that doesn't concave into itself at all? If I were to draw the lines for all the sides, we're good there. So that means this would be convex. And there are 1, 2, 3, 4, 5, 6 sides. This is a convex hexagon. So make sure you have this written down. This is going to be the big thing, knowing these names and being able to name it based on the number of sides. Now we're going to actually get into finding perimeter and area. You're going to have to use some skills that you did in 8.3, which was the distance formula. So make sure that you have those notes handy as well. So example 2 says, find the perimeter of triangle ABC with vertices A at -2, 3, B at 3, -3, C at -2, -3. So the first thing I'm going to do is I'm going to actually go ahead and graph these points here. I'm going to graph this triangle. So I'll graph A at -2, 3. Make sure you label it as you graph it. There's your point. That's at A. B is at 3, -3. So there's B. And C is at -2, -3. So that's C. I'll grab myself a straight edge and I'll connect these points to make my triangle. So I have my triangle, I have my vertices labeled. I want to find the perimeter of a triangle. Think about finding the perimeter of any polygon. Finding the perimeter is adding up all the sides. So basically, I need to be able to add up side AB with side BC with side AC. That's all the sides. Do you guys see that? AB, BC, AC, those are my three sides. I have to add all those up. So I need to know the length of all those sides. Well, the two that are horizontal and vertical lines, we can just count. When we have horizontal and vertical lines, that's super nice. We don't have to do any really crazy work. We can just count. So let's first start with BC here. BC is 1, 2, 3, 4, 5 units. So the length of BC is 5. Let's count AC. 1, 2, 3, 4, 5, 6. So the length of AC is 6. I can't just count a line that is not vertical or horizontal, so I have to instead use the distance formula. Worth noting, the distance formula, I'm going to write it down here. You have this already, we learned this in 8.3, but the distance formula is D equals 2 minus x1 squared plus y2 minus y1 squared. So I'm trying to find the distance from A to B. So that means A will be x1, y1, B will be x2, y2, and I'll go ahead and plug in the distance formula. Remember, this is going to give me the distance of AB. So I'm going to do this up here. D equals the square root, and I'll plug in my x2 is 3, x1 is minus negative 2 squared, plus y2 is negative 3 minus 3 squared. And I have minus and negatives, so that'll become plus a positive. If you want, you can type this all in your calculator at once with the square root and everything. Just make sure you use parentheses, or you can solve it in your head or solve it out. Either way, you're going to end up getting 7.81. So the distance of AB is 7.81. Now that I have all my distances, now that I know all of my side lengths, I can go ahead and add them together to find the perimeter. So the perimeter will equal my first side length, which is 7.81, plus my second side length, which is 5, plus my third side length, which is 6. So the perimeter of this triangle is 18.81. In this case, we'll just say units because we don't know if it's inches, centimeters, whatever, so we'll just put units. So the biggest thing to remember here is that perimeter is adding up all the sides, and if you have horizontal and vertical sides, you can count those. They're along the axis, so that's fine, you can count them. If you have a side that is not a horizontal or vertical line, you're actually going to have to use the distance formula to calculate it. In the next example, we're going to find the area of a triangle. It's a little bit different. We'll have to remember our area formula, and then we'll practice some of these. So the next example says find the area of triangle DEF with vertices at D, 1, 3, E, 4, negative 3, and F, negative 4, negative 3. So first thing I'm going to do is graph these vertices. D at 1, 3, E at 4, negative 3, and F at negative 4, negative 3. And again, I'll grab my straight edge and draw the triangle. It's important that you're using a ruler or straight edge because we want this to be as neat as possible so that we can use this picture to help us find the side lengths we need in order to find the area. So if I was asked to find perimeter, just to kind of review that like we were in the last problem, I would count the length of DF, and then I would have to use the distance form, I would count the length of FE, and then I would have to use the distance formula for DF and DE. But I'm asking for area. So what we're going to have to recall is the area of a triangle. In this case, the area of a triangle, because it's a three-sided figure, if this was a quadrilateral, if it was a square or rectangle, we would use a different area formula. So make sure you know what shape you're finding before you just jump into this formula. So the area formula for area of a triangle is A equals 1/2 base times height. Again, if this was a square or a rectangle or a trapezoid or anything else, we would use a different formula. So make sure you're kind of being conscious of that. Don't just blindly use this formula every time. This is just for I'm going to even write it underneath. This is just for a triangle. Okay, so if I'm going to use area of a triangle, I'm going to need to know the base and the height. Let's take a look at this triangle. My base, I'm going to make FE, and that should be easy enough to count. So I should be able to find the base relatively easily. The height has to be perpendicular to the base. So the height actually has to be this line right here from D perpendicular to the base. So I should actually be able to count that line as well. Since the base is a horizontal line, that means the height is a vertical line. I should be able to count both of those. So my base here, my B, which is side FE, is, let's count FE. 1, 2, 3, 4, 5, 6, 7, 8. So my base is 8. My height is that new side I just drew. And my height, I'll go ahead and count, I shouldn't say side, the new line I just drew, I'll count that. 1, 2, 3, 4, 5, 6. My height is 6. Now that I know my base and my height, I can go ahead and use that to actually calculate the area. A equals 1/2 base, which is 8, times height, which is 6. 8 times 6 is 48. Half of that is 24. So my area is 24. In this case, again, we're talking about units, but area is square units. We just multiplied 8 units times 6 units. When we multiply 2 units, it's square units. So this would be 24 square units. Let's take a look at the next problem. So example 4 says modeling with mathematics. It says you're building a shed in your backyard. The diagram shows the 4 vertices of the shed. Each unit in the coordinate plane represents 1 foot. Find the area of the floor of the shed. So basically they're asking us to find the area of the rectangle we have. So I know it's kind of hard to see, but we have rectangle GHJK right here. So if I'm going to find the area of a rectangle, I'm going to need to know the formula for area of a rectangle. That one you should know. If you don't know, if you get to a problem on the homework where you're like, I don't know the formula for area of a rectangle, just Google it. You can find it relatively quickly. The formula for area of a rectangle is length times width. So in this case, I'm going to pick my length, GH. I'm going to find that. And then I'm going to find my width, HJ, and I'm going to multiply those two. So let's first find GH. I can do that by actually just counting. So let's go over and count GH. 1, 2, 3, 4, 5, 6 feet, because each unit is a foot. And then let's find HJ. I could count that too. 1, 2, 3, 4, 5 feet. And to find the area, I'll go ahead and multiply those. So the area would be length times width, which is 6 times 5. So the area of this shed would be 30. Remember, it's 30 square feet. Oops. All right, the next thing we're going to do is try 4 your turn problems. So what I want you to do with these problems is I want you to try them on your own, but I'm also going to go through each of them. So pause here, try the first one. Once you feel like you've got it, watch it and see if you get the same answer as me. And then if you didn't, go back and fix it. Make sure you find your mistake. So the first one says, so again, you should pause it, try it now, and then press play when you've finished it. It says find the perimeter of the polygon with the given vertices. So first thing I'm going to do is graph them. D at -3, 2. E at 4, 2. And F at 4, -3. Once I graph it, I'm going to go ahead and use a straight edge to connect those vertices to actually draw my triangle. And then I need to find the length of each of the sides in order to actually find the perimeter. So my side lengths are DE, EF, and down here, DF. DE should be relatively easy. I can count that. So the first thing I'll do is count DE. 1, 2, 3, 4, 5, 6, 7. So DE is 7 units. EF I can also count. That looks like it's 1, 2, 3, 4, 5 units. And then DF, I'm going to actually have to use the distance formula. So I will make D x1, y1. I'll make F x2, y2. And I'll go ahead and use the distance formula. Distance formula says x2 minus x1, so that's minus -3 squared, plus y2 minus y1 squared. I'll go ahead and type that in my calculator exactly as it is. Make sure you use parentheses, and I'll get 8.6. Now that I have all of my distances, 7 plus 5 plus 8.6, I'll add those all together to get my perimeter, which should be 20.6 units, because we don't have the units. Let's try the next one. The next one's also a perimeter one. Again, try this on your own. Once you've tried it, go ahead and watch this and see if you get it. K is at -1, 1. L is at 4, 1. M is at 2, -2. And N is at -3, -2. So this is actually a quadrilateral. Finding the perimeter of a quadrilateral means I'm going to be adding 4 sides together, which is fine. I'll have to find all 4 sides and add those all together. So I'm going to start with the easy sides. The easy sides would be KL and NM, because those are horizontal lines, so I can just count. So up here, KL, if I count that, I'll get that KL is 5. NM, I'll go ahead and count NM. NM is also 5. Now I'm going to do the 2 other sides, which are going to be a little bit more difficult. I'm going to have to use the distance formula for both of those. Yeah, I'm just going to use the distance formula for both of those. So let's go ahead and do KN first. I'm going to go ahead and label K as x1, y1, and N as x2, y2. It'll be -2 minus -1 squared plus, that should be -3 minus -1 squared. Over here, it's -2 minus 1 squared. Go ahead and type that in your calculator. For Kn, you should be getting 3.6. And I'm going to use a different color here. Now I'm going to do Lm. So I'll label L now as x1, y1, and M as x2, y2. Lm is the square root of x2 is 2 minus 4 squared plus -2 minus 1 squared. I'll type that in my calculator and I'll get 3.6. The last thing I'll do is I'll add, 5 plus 5 plus 3.6 plus 3.6 to get my total perimeter, which is 17.2 units for that one. Once you feel like you're good on perimeter, let's go ahead and try 2 area ones. So I'll go down here to this next one, find the area of the polygon. I already know that it's going to be a triangle because there's 3 vertices. So let's go ahead and graph G at 2, 2. H at 3, -1. And I at -2, -1. And use a straight edge to create that triangle. Remember, area of a triangle, we went through this in the notes. Area of a triangle is 1/2 base times height. I'll make my base IH, which means my height is right here. So that's my height. This is my base. My base, I can count that, should be 1, 2, 3, 4, 5. My height, I can count my height, should be 1, 2, 3. So my area will be 1/2 5 times 3. 5 times 3 is 15. Half of 15 is 7.5. So this is 7.5 square units. And the last one. Again, try these on your own first, and then watch this. So the last one is going to be a quadrilateral. So I'll go ahead and graph N at -1, 1. P at 2, 1. Q at 2, -2. And R at -1, -2. Looks like it might be a square. I can't be certain it's a square until I count the sides and see if they're all the same, because it could just look like a square and actually be a rectangle. It doesn't really matter either way. The area for a rectangle is length times width. That works for square as well. Technically, the area of a square is side squared. Whichever way you want to do it. I'm just going to go with this is a rectangle, so I'm going to use length times width. So I'm going to call my length NP and my width PQ. So my length then would be 3. My width is also 3. So as it turns out, this is a square. So my area then would be length times width. So that's 3 times 3. So my area then would be 3 times 3 is 9 square units. So make sure you try those. If you need to, go ahead and rewatch those examples. Otherwise, that's finding perimeter and area of polygons.